Okay, so the question here says to draw a reaction coordinate diagram for a fast, stepwise reaction that favors products. Now we're going to be labeling the reactants, products, intermediate if necessary, and it is because stepwise will have 2 plus transition states. Transition states, activation energy, and Gibbs free energy of the reaction. So we're going to start by drawing the generic coordinate diagram here. On the x-axis we have reaction progress. And on the y-axis we're going to have energy. So since we know this reaction is fast, we're going to have a low activation energy. And since we have here that it's favoring the products, we know that this is going to be exothermic. So in saying that, we can know that over here our products are going to be lower energy than our starting point or starting material or our reactants, which will be kind of over here. And as we start to draw the line in, we're going to go ahead and make one transition state here, go down to our intermediate, go down to another transition state, and go down to lower energy all the way down here at our products. And the reason that I drew this so close right here to the starting material, the transition state pretty low, is because it's fast, meaning the activation energy is low. If it were to be, something that's slow, it would be something more like this in comparison, where the activation energy here is going to be like very much a lot taller than over here. But that's kind of spoiling the next part of the problem. We're going to label this thing and kind of talk about that as well. So the first thing we need to do is label the reactants or starting material, and that's going to be here. So I'm going to put SM for starting material. We could also put reactants. Either one works. And then over here on this side we have our products. And like I said, they're going to be lower energy because it's exothermic favoring products. And that means that they're going to be lower than the reactants, lower energy, because energy is going to increase in this direction up. And right here at this top hump we have one transition state and another transition state. And at this little, I guess, I don't know what you would call it, but that little dip, I guess, we have our intermediate. There's that. And switching over to blue, I'm going to go ahead and label our activation energy in delta G. So our activation energy is going to be going from our starting material up to this transition state. So that's activation energy. And then our delta G is going to be going from our starting material or reactants all the way down to our products. We can label that delta G. So since our starting materials are higher energy than our products, this is actually going to be a negative delta G. And that also has to do with the fact that this is exothermic. So just to reiterate, we had a fast stepwise reaction that favored the products. So that tells us it's going to be exothermic, have 2 transition states at least, and it's going to have a low activation energy, which is shown right here. Over here we label our reactants, we label our products over here, and we have our intermediate right in the middle at this little dip. The transition state is going to be at the top of both of these different humps right here. Activation energy goes from the starting material or reactants all the way up to the transition state, and Gibbs free energy goes from the reactants all the way down to the products. So that is basically all we have to do, and that is the entire problem.